Hello, welcome to the second supplemental demo to the talk series on spherical astronomy. In this short demo, we are going to explore the difference between solar time and sidereal time, especially solar day and sidereal day. So we are going to track the motion of the sun in the sky and the stars in the sky and set two different time steps to see what the difference is. So let me introduce the setup here. The horizontal blue line here is the celestial equator, and this wavy green line here is the ecliptic. I have changed the projection system that is being used right now to what's called equirectangular projection, where it's kind of like Mercator for the Earth. Here the upward direction is always north and the downward direction is always south. Okay, and the north pole actually gets stretched into a line. So it's a very bad projection system to use if you want to go near the North Pole. Just like a map of the Earth, you know, the North Pole gets stretched into a line, and the northern continents like Greenland get exaggerated in size. So this is the similar projection used for the sky, but near the equator it's a very useful thing. So the things to note is that in this projection system, up is north, down is south, and the celestial equator is that horizontal line that just runs through the exact center. Okay, that's this blue line, and this wavy line here is the ecliptic. Okay, so now we are going to step at the time at 1 day. So every refresh of the star map is 1 day apart, and we will watch the motion of the sun amongst the star background. Okay, so I'm going to start. So you see the sun roughly has the same location in the sky in terms of east and west, but it moves north and south along the ecliptic because the ecliptic is tilted towards the equator. So this is what causes the seasons, as we know. So as seen from the Earth, if you looked up at the sky, effectively the sun around the celestial equator moves basically north and south, like this. Let me increase the time step so that we can speed up the simulation and then see the sun come back to the southern hemisphere. Okay, so now the sun is in the southern hemisphere and so on and so forth. Okay, so now I will set the time step to this special time step, which is one sidereal day. The sun will continue to take different locations in the sky, but what is important to notice here is that the stars remain fixed. Now the screen will refresh at a rate of one sidereal day. So every time step is one sidereal day apart, and so the stars will remain basically fixed and the planets will move with respect to the star background. So that's what we are seeing here. So when I change the step back to one solar day or 1 day, then the stars are moving, and that's the one that's the extra 4 minutes of motion that corresponds to the revolution of the Earth. Okay, so with that we end this demo. Thank you.